Haley Prajapati, and this is part 5 of face recognition system. So without further ado, let's get this video started. Introduction. Face recognition system is a technology capable of matching a human face from a digital image or a video frame against a database of faces, typically employed to authenticate users through ID verification. Services works by pinpointing and measuring the facial features of a given image. This face recognition system is a natural process because people usually do it effortlessly without much conscious. It is a way of identifying an individual's identity using their face. In this slide, we'll be talking about heat maps, correlation matrices, and box plots. Heat maps are a great tool used for creating beautiful features and can provide us with insights on trends and allow us to identify the potential outliers within a dataset. Then correlation matrix allows us to identify how well or not so well the features within a dataset correlate with each other, as well as whether the correlation is positive or negative. Then box plots are a great tool for data visualization. They can be used to understand the distribution of data, whether it is skewed or not, or whether any outliers are present. We can display them using pandas and matplot in Jupyter Notebook, and it uses numeric values for plotting, and the dataset I'll be using is images, so that's not possible. Future independence plots and outlier plots. Future independent plots, it is done by using a correlation matrix or box plots or even scatter plots, where scatter plots is just a distribution of X and Y, and determining the correlation between the variables and reducing the input variables to your model by using only relevant data and getting rid of the noise in the data. Then outlier plots, it is a data point in dataset that is distant from all the other observations and are found by using boxplot or z-score formula in Python, which is, the formula is actually observation minus mean divided by the standard deviation. But my dataset only contains images, so it is not possible, as you need numeric values for plotting the graphs and all. Illustration of the pattern of interest. This system uses computer vision to identify people in images with accuracy at or above the human level, and with much greater speed and efficiency. The computer vision automatically does extraction, analysis, and classification and understanding of useful information from the image data and uses unique mathematical patterns to store the biometric data. The illustration of trends in time and space. This system uses color space, which can be referred as a color model, utilizing a symmetrical mathematical module that is used to describe color range or color components such as RGB or YCBCR color space system by combining the extracted pixel value from each color space. The below is actually the code on how I converted it to R channel, G channel, and B channel, which is RGB, but my dataset already contains the grayscale images, so I don't have to do a lot. Explore and clean data. Data cleaning is basically deleting duplicate or redundant or irrelevant values from your dataset, as duplicate observations most frequently arise during data collection and irrelevant observation. are those that don't actually fit the specific problem that you're trying to solve. And in my dataset, I barely have any duplicate or irrelevant values. Splitting data into train, valid, and test sets. Here we will be splitting data into two sets. One part is used to evaluate the test, evaluate or test the data, and the other to train the model, so it can be easier for the end user to configure any model using this data. Here is actually even the valid test also. The machine learning model. For my project, I'll be building the random forest model. Random forest model adds additional randomness to your model while growing trees. When splitting a node, it searches for the best future among a random subset of futures instead of looking for the most important future. The tune hyperparameters. The hyperparameters that I'll be tuning includes max futures and n estimators. Max futures represent the number of futures that we will be using to construct the prediction model, and n futures is actually the number of trees that we will be using to construct the prediction model. Then we'll also use the grid search CV method, which will be used to perform an executive search of optimal parameters in a grid-wise manner. Particular grid search CV function can perform the typical functions of a classifier such as fit score and predict. Evaluation on validation set. A validation set is a set of data used to train artificial intelligence with the goal of finding and optimizing the best model to solve a given problem. They are actually also known as div sets. In this model, I'll be using the RF score function that will be used to calculate the accuracy score of the RF model in predicting the test data X test. This is my Jupyter notebook. Here I'll be doing data cleaning where I imported my CSV file. Then DF preferred which will display the data, but my data set doesn't have any duplicate values or any relevant values, so I won't be moving to the data cleaning. Here I try to get the location of 100, which will give me this for happy and part-time. Then I imported my dataset using SQL to create the training and validation and test sets. Here I'll be doing the data splitting, test, validation, and training. This is the training, this is the validation, and this is the test. After I'll be using the random forest model, where I'll just import the random forest classifier from htlearn.assemble. Then I will import the accuracy score from htlearn.matrices. Then it will generate the random forest classifier. After that, this is for evaluating on the test, the X test and the Y testing sets. Then we go to hyperparameter tuning. Here I imported the grid search as we are going to use it. We are also going to use max futures and n estimators to do the tuning, to do the hyper tuning. Here we are printing the best parameters, which are starting with S with a score of 0.2f. Then this is for converting an image to RGB image, where I read the image, which is already in the folder. After that, this is how the image looks. We're going to convert it to RGB. This is the final output after converting